Okay, when this problem was originally posted, it was posted under the subjects calculus and Python, but it has since been updated to be just under Python. So I am assuming that the poster is more interested in seeing the Python code than in the calculus is involved. But here's the curve. The green curve is y equals 1/2 x to the fourth. The red curve is the absolute value of x squared minus 14. Uh, this was just a parabola that opens downward, but the region between these two blue dots, actually between this dot and this dot, used to be under the x-axis until we took the absolute value, and that flipped it over the x-axis. So we're told that there's a solid that has squares that are perpendicular to the x-axis. And we'll see a picture of what that looks like in a minute. But the side of the square is this distance minus this distance. And then the area of that square is that value squared. Okay, and it turns out that the x-coordinates of the points of intersection are about negative 2.09 and positive 2.09. So we'll be integrating from those values f of x minus g of x, the quantity squared. Here's kind of what the Python code looks like. I put some comments in here. F of x is the absolute value of x squared minus 14. G of x is 1/2 of x to the fourth. These are the functions that I use to integrate h of x and k of x. X sub 1 is a set of 1,000 x values between -4 and 4, and then y sub 1 is f of x sub 1. So that allows us to plot that graph that you saw. And y sub 2 is g of all those x sub 1 values. And here's where I cheated a little bit. Maybe you were supposed to use Python to find the coordinates of those points of intersection, but I solved it algebraically. You'll see that on the last board. And then everything else is just plotting the points. Well, actually, here's the integration value using h of r. We double that and go from 0 to I sub 2 or I2. If we use k sub r, we square k sub r and go from I sub 2 to I sub 1 to I sub 2. Okay. If we go to board 3, here's what I did on Desmos when I treated this as a calculus problem. So we're going from 0 to, this was actually x sub 1 right here. But you can see we get the same answers on Desmos. And this is what we mean by the typical square. Okay, so if I let this graph go from left to right, the square gets bigger and smaller again. All right, and then here's the work finding the x coordinates of the points of intersection. We're solving this equation. So the expression in the absolute value symbol either equals this or the opposite of that. So I have the opposite of that here, or here's that expression. If we clear the equation of fractions by multiplying every term by 2, set it equal to 0, realize this is quadratic and x squared using the quadratic formula, we get x squared equals -1 plus or minus the square root of 29. But when we take this, when we square something, we can't use this value right here. So it's -1 plus the square root of 29 under the radical. Those are the x values, and that's that -2.09 ... And over here, if we try the same thing we get a discriminant that's negative, so there are no solutions here. Okay, there you go. Hope that helped. If you have any questions, post a comment.